of the economy. In the recent year, there is a lot of expressway, 6 and 4 lanes roads, provincial roads have been constructed. Even in the rural area, vast network of roads has been created, resulting in vast use of passenger and commercial vehicles. The fuel used for both rail and road transport was previously fossil fuel. The railways have almost completely shifted to electrical locomotives, but keeping in view of smaller capacity engines, there is no sign of electrical vehicles. The main drawback of fossil fuel is their limited availability and its adverse impact on environment. Our country is committed to net zero emission by the year to 2070 on international platform. To reduce carbon emission, use of electrical vehicle has become a necessity. Previously, electric vehicles were not viable economically and technically, but the recent advancement has made electrical vehicle a viable option, and the use of it is increasing. The Institution of Engineers India feel it is duty to discuss various aspects of development of electrical vehicles. For this purpose, this webinar has been organized. The expert of field will make deliberation and give their recommendations, which will benefit to all the concern of this bill. Thanks to all, sir. Hello.
Yes, sir.
Okay. Next.
Chakravarti, sir.
Very sir.
You may adjust your camera, sir. Hello.
Hello.
Sir. Should we proceed further?
Next item. Chakravarti sir.
Yes, sir.
Our next item, next
Okay. Okay, sir. Thank you, sir. We have assembled here for this webinar being organized by Gorakhpur Local Center on increasing use of electrical vehicle and its advantages. I have the privilege of introducing today's moderator, Engineer M.P. Kandoi, who is also Executive Committee member of Gorakhpur Local Center. Mr. M.P. Kandoi is Bachelor of Science in year 1969 and Bachelor of Mechanical Engineer in year 1973 from Gorakhpur University. Joined Irrigation Department in UP in the year 1973 as Assistant Engineer and retired from senior-most position in the year 2011 from Lucknow. He was also a member of the Board of Studies of Mechanical Engineering and also Chairman Advisory Committee of Mechanical Engineering Department of Madan Mohan Malaviya University of Technology, Gorakhpur. At present, he is a member of Internal Quality Assessment Committee of same university. He is also technical advisor of Rotary Foundation. We are lucky to have him today as our moderator. And now I invite Mr. Kandoi to take over the charge of this function. Thank you, sir.
Thank you, sir. Now, as moderator, my first. Hello.
Yes, sir. Please continue.
Yes, sir, I am speaking. I want to. Sir, I am बंद कर रहा हूँ. कितने दिन तक बंद करो? Okay. Hello. Now, I as moderator. Hello.
Yes, sir. Please continue, sir. You're audible.
My sound is coming.
Yes, sir. Yes, sir. Very much.
As moderator, I want to introduce first Dr. K.S. Verma, who is our first panelist. Dr. K.S. Verma is Professor, Department of Electrical Engineering, Kamala Nehru Institute of Technology, Sultanpur. Now I'm going through a brief biodata of him. First of all, I want to thank him for attending the conference, for giving his precious time, and we are lucky that we have in between us such a knowledgeable person. Mr. Verma did his BTech in year 1987 with honors from PML University, Faizabad, and did it MTech Electrical Engineering in year 1998 from RML, our University, Faizabad, having topic effect of series junction compensation on static voltage stability, and PhD in electrical engineering from IIT Roorkee in year 2003. His topic was optimal transmission dispatch using facts given in open power market. His area of teaching and planning interest are first power system, second is power quality, third is flexible AC transmission system, fifth is planning and operation of distributed generation, fourth, sixth is modeling and simulation of power system. Sri Verma has a teaching experience of approximately 33 years from post of teaching assistant to teaching assistant to post of professor. He has also got an administrative experience of 8 years, 3 months as director KNIT Sultanpur, principal MKRE Ambedkar Nagar and director REC Ambedkar Nagar. He has to his credit 69 journal publications, out of which 62 are in international journals, 57 published plus 500 and 7 in national journals. He has 38 publications in conferences oblique seminar, out of which 30 are in international conferences, 8 in national conference. Further, he has supervised 8 completed PhD and 6 ongoing PhD. He has also supervised 26 MTech, out of which 24 are complete and 2 are ongoing. He has also and patent published smart e-rickshaw powered by solar PV with MUPT technique and controlled by intelligent positioning system. He is also a member of various professional bodies, had written many books, teaching material. He has also made several foreign visits to his credit for academic purpose. Today, he is presenting a PowerPoint projection about application of electrical vehicles, in which he will explain first area in electrical engineering, brief history of electrical cars, mechanical composition, e-technical vehicle, and explain other electrical portion used in electrical vehicles and their selection criteria and research development in electrical industry. Last thing say, Mr. Verma has made his PPT very much interesting by putting the several historical facts. Now, I request Mr. Verma to participate and deliver his keynote address and lecture. Thank you. Verma sir?
I think Verma sir is having some problem of internet due to power cutoff in his institute.
He will coming, sir. Soon he will be
But
coming. I'm ringing him.
yeah, he has joined now. Yeah.
Yes, he has joined.
Yes.
Verma sir,
हाँ
now
हाँ
it's your turn to speak, sir.
अंदर की
I
लाइट
will
ठीक करो यार.
Now it's your turn to speak. Verma sir?
एक्चुअली कंडू
Yes. Hello, बोलिए चक्रवर्ती साहब. Hello.
हाँ यस यस attitude. That's why the problem is here. This few seconds. Just wait. Kandoyi साहब,
Verma sir, your voice is cutting, cracking.
Yes, sir. He has asked me to wait, sir.
yes. For this, we are waiting for electricity. If electricity is available on internet, and we will able to have the lectures. Should I start?
Yes,
Do
yes,
you
please start. Start, please start, sir.
Yes. Institute of Force been very much
Sir, your sound is not clear.
connect. It is not due to net problem. Net issue is there here in store. Electricity is, that's why there is no internet. कंडोई साहब सुनाई पड़ रहा है कि नहीं हो रहा है आवाज मेरी?
हाँ सुन रहे हैं सर, आपकी आवाज आ रही है. We are hearing the sound clearly. Hello.
मोबाइल से इंटरनेट कनेक्ट करने से क्या हो रहा है कि बार बार हाँ
Sir, you switch off your video, I think. Maybe net strength
Hello?
is not good.
internet connection video.
Yes, switch off your video, sir.
Yes.
Maybe
Yes.
net strength is not good.
It's video. My
Sir, Verma sir is having problem with internet.
I think
Can we
there is-
continue with Dr. Shekhar Yadav and come back to Verma sir when the internet connectivity is restored?
Sir, Parthi साहब, वर्मा साहब, वर्मा साहब.
यस आ गई, लाइट आ गई है, लाइट
हाँ ठीक है, चलिए.
लग गई है, बस कर रहे हैं, ऐड कर रहे हैं. थोड़ा 2 मिनट रुकिए. ओके.
How much dependent we are on light? How are you?
I am audible.
Okay, audible.
Yes. Now internet has been connected. Now start the lectures.
Okay, sir.
Very thankful to all officials of Institution of Engineers, Gorakhpur Center, for providing me this opportunity to have the discussion on increasing use of electric vehicles and its advantages seminar. The organizer of this seminar is very much thankful due to because of the reason that we are switching very much towards the use of electric vehicle, as Uttar Pradesh Electric Vehicle Manufacturing and Mobility Policy 2019 has been passed, and the motivation towards this is that we will have a good quality of electric vehicle material as well as cheap car near future, and so that everyone can be benefited with the use of this electric vehicle. Now I will share some slides. Screen is sharing. Is it visible? Is it visible to everyone?
Yes, sir.
Yeah. So I will discuss about the application of electric cars, and as we know that there is a lot of thrust area in electrical engineering, and these thrust area is very much related with the electric vehicles. We have innovation and startup cells. We have research and development in this electric vehicle areas. Some of my students are working in this electric vehicles area. But these topics of electrical engineering is very much related with the electric vehicles, say generation, transmission and distribution, restructured power systems, fax devices, power quality, load and price forecasting, optimal power flow, advanced switchgear and protection, smart grid and microgrid, smart meters, SCADA system, drive and control electric machines, distributed generation, renewable energy resources, and then finally electric vehicles. So every technology is very much related with each other, and someone who will engage the research and development, then he has to learn a lot regarding these topics. Now, before discussing about electric cars, I will have some salient features regarding the Uttar Pradesh Electric Vehicle Manufacturing and Mobility Policy 2019. Salient features I will discuss. The electric vehicles are widely gaining market across the globe due to high pressure and fast depletion of fossil fuels. Electric mobility has become necessary to reduce impact of transportation on environment and climate change. The recent Paris Agreement, enforced in November 2016, provides to limit carbon dioxide emission to control global warming and threats of climate change. Electrification of automotive industry aims at achieving the set objective by decarbonizing the transport system. It is very essential. These points are very essential to limit the carbon dioxide emission, to control global warming and threats of climate change. Now, Indian automobile industry is one of the largest growing industry in the world. And the sector promises further growth in manufacturing sector, driving country's economic growth. They are very much related with each other. Since presently, the automobile industry largely contributes to pollution, the government is promoting electric mobility towards this. The electric vehicle market in India is set to go enormous and is estimated to be around 80 lakhs by 2020 and approximately 5 crores by 2030. Prices of lithium batteries are rapidly going down, thereby making electric vehicles cheaper. Electric vehicles storage opportunities in gigawatt in India is anticipated to grow at CAGR 40% till to 2022. In order to boost the manufacturing of hybrid and electric vehicles in India, Government of India has launched the faster adoption and manufacturing of hybrid and electric vehicle in India FAME scheme in 2015 under National Electric Mobility Mission Plan, NEMMP, with an aim to promote eco-friendly vehicles in the country. It has set an ambitious target of 6 to 7 million sales of hybrid and electric vehicles year on year from 2020 onwards in India, thereby creating wide opportunity in electric vehicle manufacturing. Extending the scheme, Government of India has come up with FAME's second and National Mission on Electric Mobility and Battery Storage has been launched. Indian automobile industry became the fourth largest in the world by producing a total of nearly 30.92 million vehicles, including passenger vehicles, commercial vehicles, three-wheelers, two-wheelers in April-March 2019 as against 29.09 million in April-March 2018, registering a growth of 6.26% over the same period last year. Domestic automobile production increased at 7.08% CAGR between year 2013 to 18. India is also a prominent auto exporter, where automobile exports grew 15.54% during April-March, and now the country is also on course to become the third largest producer of car in the world. अच्छा, स्लाइड अभी मूव करते हैं, थोड़ा सा मैं सेलिएंट फीचर बोल दूं तब इसके बाद बताता हूं, ठीक? Actually, slide will move ahead, but before covering these points, there is some salient feature of this policy. Okay, the industrial corridors in the NCR region, including Noida Industrial Area, Greater Noida Industrial Area, Yamuna Expressway Industrial Area, and state capital Lucknow are major contributors to the growth of automobile industry in UP. Besides, given to the large SME manufacturing base in automobile sector, छोटे-छोटे उद्योग धंधे लगा करके हम लोग ऑटोमोबाइल सेक्टर को इनरिच कर रहे हैं. कानपुर, लखनऊ, नोएडा, गाजियाबाद, अलीगढ़, आगरा, मेरठ, झांसी are other investment zones. Other zones involved in manufacturing battery in the state are located across Greater Noida, Ghaziabad, Fatehpur, Kanpur, Lucknow, Gorakhpur. Now, key opportunities with this electric vehicle mobilities, automobile and components manufacturing will increase, battery and battery parts manufacturing will increase, and charging infrastructure will increase. So the policy highlights Uttar Pradesh Electric Vehicle Manufacturing and Mobility Policy 2018 highlights the manufacturing, charging infrastructure and demand creation. There is a lot of growth of employment in this area, having the electric vehicle. Now, charging infrastructure in public buildings and public places shall be developed, and provisions to set up charging outlet, regular electric supply will be permitted. UP SRTC depot, buses, terminals, and bus stops will have charging stations. Public parking spaces will be mandated to have charging stations. In addition to these, to promote electric vehicle mobility on prominent highways such as Yamuna Expressway, Agra Lucknow Expressway, and upcoming expressways including Purvanchal Expressway with heavy density of vehicles, fast charging stations, battery swapping infrastructure at every 50 kilometers will be promoted. Now, in transition phase, the state shall promote use of methanol fuel cells for electric hybrid cars. Further, to overcome the hazards of lithium batteries, the state aims at promoting development and use of hydrogen-powered fuel cells and solar-powered cells. Also, private developers will be allowed to set up hydrogen stations, electric vehicle batteries units, and service providers will be incentivized to adopt such technologies in UP. Now, there should be proper research and development and startup and innovation. Startup policy 2017 has included the promotion of EV manufacturing. So many policies has been made and for the development of this electric car in near future in Uttar Pradesh as well as in India. So naturally, technically we will talk about the electric vehicles, and we will have some brief history of this electric car. The first known electric car was built by chemist Robert Davidson in Aberdeen, Scotland in 1837 to 48 years earlier than the first internal combustion car. First internal combustion car was developed. Before 48 years, this electric vehicle has been invented. Now, second step was the Thomas Parker, an English inventor, built the first practical electric car in London in 1884 and started production soon thereafter. Next, Thomas Alva Edison recommended Henry Ford to manufacture electric car rather than internal combustion car, and is credited in saying what he said. He said that electricity is the thing. There is no hearing. There is no hearing and grinding gears with their numerous levers to confuse. There is not that almost terrifying, uncertain throb and whir of the powerful combustion engine. There is no water circulating system to get out of order, no dangerous and evil smelling gasoline, and no noise. He has make a thrust to use of electric vehicle because this has no noise and smelling gasoline. That's why he suggested to use the electric vehicle. Now, still the short range, time to recharge and low top speed of electric vehicles led to worldwide decline in their use. In 1935, they had all but disappeared. The early 60s marked the rebirth of electric cars based on the need to reduce contamination from exhaust emissions and dependency on imported oil. The दो समस्याएं हैं, exhaust emission and dependency on imported oil. ये समस्या, इलेक्ट्रिक कार फिर सोचने लगे लोग. नाउ बर्निंग कोल और नेचुरल गैस एट ए जनरेशन प्लांट टू प्रोड्यूस इलेक्ट्रिसिटी टू लेटर पावर इलेक्ट्रिक कार इज क्लियरली not the smallest way to reduce pollution and CO2 emissions, although still better than gasoline vehicles. Now, what's exciting about electric car in the near future? Distributed solar in rooftops charging. There is a research is going on in this area. Solar system in rooftops so that charging may be easy. Clean batteries, hopefully flash charge batteries in the basement that charges. Electric cars at any time of the day or night in 15 minutes or less, hopefully car powered by flash charge batteries. These four amendments, these four changes will put the electric vehicle in the use, and for electric car to become the vehicle of choice and reduce pollution from fossil fuel combustion, manufacturers only need is a battery that charges fast, powers car for 100 miles or more, delivers more power for instant response, and is non-flammable. This is again advantage of using electric vehicle. Now, what are the this electric vehicle mechanism composition? Three major components of interconnections: propulsion system, rails, and then energy sources and auxiliary power. The electric propulsion system generates the necessary power to the wheels, includes transmission and energy management system. Energy source consists of energy sources like fossil fuel, battery or fuel cells, generates or accepts energy. Auxiliary power system supplies power to auxiliary like AC fans, lighting system. So three major component of this electric car is electric propulsion system, and energy source, and auxiliary power system. Now this is electric motor used in electric vehicle. Electric motor, here you see that this is the electric motor, and this is battery and fuel. Simply two components, major components are there. What are the various electric motors used in electric vehicles? The electric motors used for automotive applications should have characteristics like high starting torque, high power density, and good efficiency. How you will get the high starting torque? Naturally, DC series motor, if we see torque speed characteristic of the DC series motor, then this DC series motor will provides very high torque at lower speed. And this is quite good for electric traction purposes. Meanwhile, brushless DC motors, permanent magnet synchronous motor, PMSM motors is widely used. Three-phase AC induction motors nowadays, electric trains are converting from DC series motor to three-phase AC induction motors. Now, switched reluctance motor again is quite good use in the electric vehicles. Now, one by one, we will have, say, DC series motor, high starting torque capability. Traction application in early, these DC series motors are widely used in electric trains. Easy speed control, and it can also withstand a sudden increase in the load. Ideal traction motor, it is said, ideal traction. Drawback of this motor is high maintenance due to brushes and commutators are used widely in Indian railways. Now, brushless DC motor, it is very DC motors, it is very have permanent called brushless because it does not have the commutator and brush arrangement. The commutation is done electronically in this motor because of this BLDC motor are maintenance free. It is very high starting torque, high efficiency, around 95 to 98%. That's why VLDC motors are most preferred motor for the electric vehicles application due to its traction characteristic. Now, these motors are two types. One is VLDC inner. This is VLDC motors are two types. One is outrunner type motor. This motor is being fitted in the wheels directly like this. Now, this is outer case type motor. The main drawback is high cost due to permanent magnets. इस तरीके का मोटर्स होता है, इस तरीके से मोटर डिजाइन करते हैं और उसको इस तरीके से गियर एंड पुली के माध्यम से इसको इस सिस्टम में जोड़ते हैं. Now this permanent magnet synchronous motors, PMSM motors, this having increased efficiency than the later motor. PMSM is the also costlier than BLDC motor. Most of the automatic manufacturers use PMSM motors for their hybrid and electric vehicles. Say, for example, Toyota Prius, Servet Bolt, electric vehicle, Ford Focus Electric, Zero motorcycle S/SR, Nissan Leaf, Hyundai Accord, BMW i3 uses PMSM motor for propulsion. This is three-phase induction motor. It is very simple one, and we know that stator and rotor are there. A rotor is fitted and having high efficiency. It is because of less losses. Tata Motors have planned to use induction motors in their cars. This is torque speed characteristic again, and we can have a variation in the torque speed characteristic with the induction motor, and that's why this traction is changing their motor with three-phase induction motor. Now, this is the switched reluctance motor is widely used, but the biggest drawback of this switched reluctance motor is the complexity in the control and increase in the switching circuit. This is again once commercial market. It can replace the PMSM and induction motor in the near future with great efficiency. हाँ सर, अभी एक्सपर्ट लेक्चर ले रहे हैं. हाँ, आधे घंटे बाद यहाँ से चलेंगे. ठीक. So how we will select the motor for which purposes? This is very important. Now we have to see the operating condition and the cost associated with it. Where we use for example, go-kart vehicle and two-wheeler applications which requires less performance, mostly less than 3 kilowatt at low cost, it is good to go with BLDC hub motors. For three-wheelers and two-wheelers, it is good to choose BLDC motors with and without an external gear system. For high power applications like performance two-wheelers, cars, buses, trucks, and ideal motors, choice would be PMSM or induction motors. Once the synchronous reluctance motor and switched reluctance motors are made cost effective and PMSM or induction motor, then one can have more options for motor types of electric vehicles applications. However, these 3 or 5 types of motor can be used depending upon their operating condition and cost of associated with it. Another thing is that speed control is very essential part of these motors because we have to stop the motors. Their braking and stopping characteristic, their load characteristic should be very much matched with the required conditions. Now, what is the MATLAB Simulink? Is a powerful tool that lets you design and validate your electric vehicles. That is, electric vehicle can be validated with the help of this MATLAB Simulink tool, and this Simulink can be used to have the tune regenerative braking algorithms, explore electric power train architectures, modify suspension design, optimize vehicle performance, develop active chassis control, validate ADAS algorithms, test using hardware in the loop, HIL loop. So we can have the facilities to optimize the vehicle. First, we have to model the vehicle and then make a simulink for MATLAB simulink, and then we will study and research and development can be done with the help of this MATLAB software. Now, what are the different types of electric vehicles? Means battery operated, hydrogen electric vehicles, and fuel cell electric vehicles. We can have the compression, propulsion, energy system, energy source and infrastructure, characteristic and major issues. What are the major issues? We can have the compression with the fuel cell, hydrogen electric vehicles, and battery operated electric vehicles. So electric high fuel cost, lack of infrastructure, we can see the slides, and we can have the comparison between these three electric vehicles. Now, electric vehicles need modeling because of following reasons. Many configurations, energy management control strategies, analytical solution difficult, prototyping and testing is expensive and time consuming. Simulation tools we can use have SimLab, Marvel, VELPH, Advisor, and others, PSAT, CarSim. So many softwares are available to have the performance, to check the performance, to check the running condition of the fuel car, electric vehicles before taking in the operation. Now, copper used, this is not a course coverage here. What are the benefits of electric transportation? Again, we will see in the next. Now, electric car in India. The list of electric cars in India include Tata Tigor EV, 12.24 lakhs, Tata Nexon, 15.54 lakhs, and MG ZS EV, 25.88 lakhs. Depending upon the technology, the cost of or price of this electric vehicle is being increased. Now, what are the potential gains from the electric vehicles? Now, first potential gain is better air quality. Better air quality means improving public health in cities. It is very essential part. Now, second is the greenhouse gases mitigation. It's again towards a greener India. This electric vehicles plays very important role regarding the better air quality, greenhouse gases mitigation. Then promotes renewables through electric vehicles. Renewable energy resources is being used, maybe solar, wind, or any other renewable resources of power generation or charging of batteries can be used to charge the electric vehicle. Now, this is enhanced energy security. Reduces imported fuel use in transport sector. Say imported fuels means this petrol, diesel is required, will be less required, because we have to depend for petrol and diesel to other countries, on other countries. And this will reduce the imported fuel use in the transport sector. Now, increases plant load factor, because vehicle uses renewable energy. That's why it increases efficiency of power plants. Naturally, they will not take the power from main power stations. The solar panels and all renewable energy resources can be utilized for the charging of these electric vehicles. Now, one thing is that very important that private participation, private electric vehicle parks for charging. The government of Uttar Pradesh will provide incentive to the developers of private EV parks and clusters with plug and play facilities. The park must be developed over more than 150 acres of land and must include manufacturing area, R&D and testing centers, battery manufacturing and handling areas, common facilities, recycling ecosystem, waste treatment facilities. So employment facility is also available with this. Technological leadership position India as a leader in auto technology. This is very important. No? What is the growth? Day by day, the electric cars, the production is growing and use of electric cars is going on. Now, composition of the vehicle fleet, passengers vehicles, commercial vehicles, three-wheelers, कितने बने हैं, कितने तक इनकी 90%, 98% of the vehicles, small and affordable vehicles, two-wheelers and economic cars, public transport and goods vehicles, three-wheelers, small good vehicles, buses and trucks has been made, and only 2% of the vehicles are high and end car, unlike in developed countries. Now, this is the share of in distance kilometer, how much and the trips are of less than 5 kilometers, 71%, and of the trips are of length greater than 10 kilometers is 16%. Now, this is the Electric Mobility Forum has been made, and this the function of this Electric Mobility Forum is the convening, mentoring, and scaling. These three agenda of these mobility electric vehicles. A guidance document on accelerating electric mobility in India, a reference WRI India, and this you can see Center for Battery Engineering in IIT Madras. We can see that how the mobility is made in India. Now, national and state electric vehicle policies we can have by taking this copy of these sites and putting on Google link, and then everything will be clear in studying the advantages and what is the development in the electric vehicle area. Now, pillars of electric mobility ecosystem is that electric vehicles are electric plug-in hybrid vehicles and re-energizing system, charging and swapping infrastructure. Then batteries, lithium-ion batteries, NMC, LTO, LFP battery management system. Other factors, manufacturing capacity, research and development, power grid. Means mobility ecosystems have four major components where we can have the R&D and where we can have the research and development in the area of electric vehicle, and this startup and innovation cell we can have. And in Uttar Pradesh, we are seeing a lot of incubation and startups, academic tie-up and research with the academic institutions, patent and quality certifications. One of my research scholars have one patent in the electric vehicle area. Then testing facilities should be there in Uttar Pradesh, so that electric vehicle mobility incentive coming Department of Industries, Government of Uttar Pradesh will integrate the mobility incentive provided by the Government of India to promote electric vehicles and mobility. Now, it is very easy business. Single window, single sanction is there, simplifying procedures, quality, power permits, industrial security. So many policies has been made in Uttar Pradesh to have the major thrust in the electric vehicle area. So thanks for your kind attention. Pandoi Saab?
Yes, sir. Now I want to thank Baba Saab for your precious time. The time was too short, having the vast knowledge.
Actually, in beginning, we have some problem of this.
Sir, never mind, sir. We engineers are made to solve the problem arise.
Okay.
Again, I thank Mr. Verma sir for his precious time, and I will request him to wait till 2 p.m. Then the 105 to 155 will be question answer sensor. Sir, you have given a general layout, general
Yes.
broad outline of electrical vehicles. Thank you again
Yeah.
very much. Okay, sir. Thank you.
So should
Now,
I close the
yes,
sharing?
you can go out, sir. You
Yes.
can leave the.
Thank you
But
very
you
much.
will not leave the webinar, sir. But you will not leave the webinar.
I think this course, this seminar is very beneficial in the study of electric vehicle, because this is emerging technology in electrical engineering as well. In electrical, electronics, mechanical, civil, it is interdisciplinary research is required for the innovation in the electric vehicles.
Okay, sir. Thank you. Remain till the question and answer session ends, sir. People may raise queries from you, and
Okay.
we will not get opportunity for learned people like you. Okay.
Thank you. Thank you very much.
Sir, KG Upadhyay sahab. KG Upadhyay sahab. KG Upadhyay sahab.
उपाध्याय साहब आ तो गए हैं,
आ गए हैं, उनको
हाँ।
अनम्यूट कीजिए सर।
अनम्यूट करना है सर, अनम्यूट करिए।
हेलो उपाध्याय साहब।
अभी जस्ट ट्रेवल में हूँ, 10 मिनट बाद, तब तक शेखर को इंडक्ट कर लीजिए।
अच्छा, ओके, आई एम कॉलिंग शेखर नाउ। ओके, शेखर यादव साहब।
Yes, sir. Yes, sir. Yes, sir.
Are you there in the meeting?
Yes, sir. Yes, sir.
Now I will call our second panelist, Dr. Shekhar Yadav. He will give you. I am giving a brief introduction of Shekhar Yadav. Shekhar Yadav is at present Assistant Professor Electrical Engineering Department, Madan Mohan Malviya University of Technology. Dr. Yadav did his BTech in Electrical Engineering from Institute of Technology, Royalkhand University, Bareilly in year 20007. He did his MTech Control System for Electrical Engineering and from Electrical Engineering Department, IIT BHU, and PhD in year Electrical Engineering from Indian Institute of Technology. His topic of research was some aspect of intelligent control of non-linear capacity. He has worked in Madan Mohan Malviya University of Technology since in joining many academic and administrative programs. Mr. Yadav, in his lecture, will apprise about the motor drive system used in electrical vehicles and various aspects of control system. Now, Mr. Yadav, I want to hand over the mic to you. Please.
Thank you. Thank you very much, sir. Thank you all the organizers for giving me this opportunity to share my view on the electric vehicles. Though my area of expertise is control system, so I'm just giving a very basic overview of electric vehicles. And I think Professor Verma has covered all the aspect of electric vehicles. So I will try to justify my talk. So I will share my PPT. Just wait a minute. Is my PPT is visible? Is my PPT is visible, sir? Please confirm. Andoy, sir? Okay.
Okay, sir.
Okay, sir. So to start with this topic on electric vehicles, we can say that this is the most demanding topic in this current scenario, because nowadays the research as well as the government of focusing to being the use of electric vehicles. So why we are focusing on electric vehicles? So these are the basic content of my talk, that is introduction of electric vehicles. Then why we are focusing towards EV. Then the benefit of EVs, then type of EVs, then motor drive technology, classification of EV motors, then conclusion in motor system. So this is the general content which I am covering today. So why we are focusing on electric vehicles? The major, just wait a minute. Okay. So why we are focusing on electric vehicles? Because we know that around 6 to 10 billion of global population will increase into upcoming 40 years. So this is the main reason that our population is increasing day by day. So we are more relying on the users of vehicles. So previously we are using the internal combustion based engine, but due to the various problems related to internal combustion based engine, we are focusing towards use of electric vehicles. And in upcoming 40 years, we can say that around 0.7 to 2.5 billion of our countries will basically rely on electric vehicles. As we know that the conventional internal combustion based engine vehicle is not useful because high emission and petroleum consumption, and the prices of and as well as diesel is increasing day by day. And also I request all the participants please mute because I am getting some disturbances. So we can say that the problem associated with the petroleum or as well as diesel is in terms of the emission of pollution. We are just focusing towards the use of electric vehicles. And we also know that electric vehicles gives a better solution for all these problems. The society and the government are thinking about this alternative solution. Toyota has produced the world's first hybrid electric vehicle in mass scale, and it named Toyota Prius. In this vehicle, both IC engine as well as the permanent magnet brushless DC motor is synchronized. So that is why it is called a hybrid electric vehicle, and it is synchronized in a manner so that we can use both the features of internal combustion, that is the conventional approach, as well as the modern approach, which is known as the electric vehicle. Okay, so in this machine, both internal combustion as well as the motor is synchronized in a manner that give you better opportunity to work with this. So both EVs as well as HEVs has various advantages that has make popular for its various applications. Now the question raises that why we are more focusing towards the use of EVs only. So we know that the availability of fossil fuel is very much limited, and their use is destroying our planet day by day. The toxic emission from petrol and diesel vehicles lead to long-term adverse effects on public health. The emission impact of electric vehicle is much more lower than the petrol as well as diesel vehicles. From an efficiency perspective, electric vehicles can convert around 60% of the electrical energy from the grid to power the wheels. But petrol or diesel cars can only convert 70 to 21% energy stored in the fuel to the wheels. So we can say that there is a waste of around 80% while using the internal combustion based engine. And also we know that the fully electrical vehicles will have zero tailpipe emissions, but even when electricity production is considered on the basis of renewable energy, the petrol or diesel vehicles emit almost around 3 times more carbon dioxide than the average electric vehicles. To reduce the impact of charging electric vehicles, India is ambitious to achieve about 40% cumulative electric power installed capacity from non-fossil fuel based resources by 2030. Therefore, we can say that the electric vehicles are the way forward for Indian transport, and we must switch to them now. The benefits of electric vehicles, we can say that they have low running cost, low maintenance cost, they produce zero tailpipe emission, they are easy to drive because they won't have clutches, and as well as the gearing system is also automatic. The convenience of charging at home is also gives a better flexibility to the person as well as the society to charge your vehicle at your parking locations. They produce no noise, so the noise pollution is also a big problem in India because the internal combustion engine makes a huge sound, so it removed that also. So the lower running cost is because the running cost of electric vehicle is much lower than equivalent petrol or diesel engine. We know that. As we also know that the electric vehicles use electricity to charge their battery instead of using fossil fuel like petrol or diesel. So we can say that electric vehicles are more efficient as they combine the electricity cost, means that charging an electric vehicle is cheaper than filling petrol or diesel from an travel requirement. And also, if we use renewable energy to charge these electric vehicles, then it becomes more eco-friendly as compared to the conventional internal combustion based engine. So the running cost is also low. The maintenance cost is also low because electric vehicles will mainly have very low moving part. We can say that the moving part of an internal combustion engine has, as compared to the internal combustion engine, electric vehicle has very low moving part. So the maintenance cost is also low. The service requirement for electric vehicles are lesser than the conventional petrol or diesel vehicles. Therefore, the yearly cost of a running of electric vehicle is significantly low as compared to internal combustion based engine. The electric vehicles emit zero tailpipe emission because we know that driving an electric vehicle can help you to reduce your carbon footprint because there will be zero tailpipe emissions. You can reduce the environmental impact of charging your vehicle further by choosing renewable energy options for home electricity. Ease of drive. We can say that the electric vehicle is basically comprised of automatic gearing system. So the driving skills of electric vehicle is much more convenient than the conventional vehicles that we used. In this electric vehicles, we have only motors and automatic gears, and by which we can say that the driving is also easy as compared to the conventional system. Now, we can say that the charging of electric vehicles is much more easy because we can charge our vehicle at our home, and also there are various facilities of charging the vehicle. As we can say that there are on-board charger, there may be off-board charger. We can also replace our battery. This facility will become sooner. Then we can replace our battery and we can charge our battery in charging stacks. So the charging problem can be reduced after having the fast charger, even battery swapping services at various places. Electric vehicles will produce no noise pollution because we can say that the electric vehicles electric motors functionally so silently that you need to peek into your instrument panel to check if it is on. So when the electric vehicle is running on the road, we have to check that whether this motor is running or not, because it is so silent, it produces no noise. And in fact, some of the manufacturers has to add some false sound in order to make them safe for the pedestrians. Okay. Now we will discuss some of the type of electric vehicles. that are basically used nowadays, and these types are somehow comprised of battery-based electric vehicle, the hybrid electric based vehicle, the plug-in electric based vehicle, and as well as the fuel cell electric based vehicle. So these electric vehicles are somewhat has its own advantages compared to its own categories. We know that the battery electric vehicles are also known as all electric vehicles. Electric vehicles using battery BEV technology run entirely on battery powered electric drive. The electricity used to drive the vehicle is stored in a large battery pack, which can be charged by plugging into the electricity grid. The charged battery pack then provides power to one or more electric motors to run the electric car. The main component of battery electric vehicles are the electric motor, the inverter, the battery, the control module, and the drivetrain. The working principle of battery electric vehicle is the power for electric motor is converted to DC to AC. As we press the accelerator, a signal is sent to the controller. So the controller is used to adjust the speed of the vehicle by changing the frequency of the AC power from the inverter to the motor. The motor then connects and leads to the turning of wheels around a cog. If the brakes are pressed or the electric car is deaccelerating, the motor becomes an alternator and produces power, which is sent back to the battery. So the examples of battery-based electric vehicles are Morris Garage, ZS, then Tata Nexon, then Tata Tigor, Mahindra E2O Plus, Hyundai Kona, and Mahindra Vereto. So all these electric cars is basically available in India nowadays, and few of the cars are upcoming. Now, the another category of electric vehicles are hybrid electric vehicles, and these vehicles have both the internal combustion based engine as well as the electric motor. Okay, so these hybrid electric vehicles have its own advantages, that the dependency on the battery is not that much reliable, as we can say that the working principle of HEV is basically it has a fuel tank that supplies energy to the engine like a regular car. The battery is run on an electric motor, so both the engine and electric motor can turn the transmission at the same time. The example of hybrid electric vehicle are like the Toyota Prius, the Camry Hybrid, the Ford C-Max, Honda CRZ, and the Kia Optima Hybrid. So few of the cars are available in India and few are upcoming very soon. The next category of electric vehicle are plug-in hybrid electric vehicle. They are also known as PHEVs. They also have both engine and a motor. You can choose among the fuel convenient such as petrol or alternative fuels such as biodiesel. It can also powered by a rechargeable battery pack. The battery can be charged externally. So the PHEVs can run in two modes. The two modes can be all electric mode and the hybrid mode. The main components of PHEVs are electric motor, engine, inverter, battery, fuel tank, control module, and battery charger. So these PHEVs is working on the basis of charging by plugging into an outside electric power source, engine, or regenerative braking. So when the brakes are applied, the electric motor acts as a generator using the energy to charge the battery. The engine power is supplemented by the electric motor. As a result, a smaller engine can be used, increasing the car fuel efficiency without compromising performance. So the example of PHEVs are Fiat 500e, the Hyundai Sonata, the Kia Optima, and the Volvo XC90. And there are many more cars based on PHEVs. The next category is based on the fuel cell EVs. So this fuel cell EVs basically used the fuel cell as well as the battery, and there is one more category, that is they may use ultra capacitor as the secondary fuel, and also they can use the ultra flywheel electric vehicles. But the common secondary fuel is battery for all these type of electric vehicles. They use two categories of fuels, that is, one is battery and another is either ultra capacitor, ultra flywheel, or they can use fuel cell. So the main components of this fuel cell electric vehicle are once again the electric motor, the fuel cell stack, the hydrogen storage tank, the battery with converter and controller. So the working principle is generally, it basically runs on both the fuels, that is on the electricity as well as on the fuel cell. The examples of fuel cell electric vehicles are Toyota Mirai, the Reverse Simple Rasa, the Hyundai Tucson, and Hyundai Clarity, and many more. Now we see that how this internal combustion based engine and the electric vehicle, how they will run. So we can see from this figure, in case of internal combustion based engine, the force speed characteristic is basically comprised of, in this internal combustion based engine, we have 5 gears. We have the first gear, we can see over here, the second, the third, and the fourth and the fifth. So in internal combustion based engine, we have several gears with us, and the force speed characteristic, during the first gear, we can say that it has very high torque in the shaft, and which can enable a low speed operation. So this mode is required for starting and acceleration. So when the vehicle is required to go at high speed, we need to change these gears from first to fifth gear. But as we can see from the electric vehicle perspective, these gears are missing in electric vehicle. But in case of internal combustion based engine, the gears are available, and the torque can be varied while changing the gear of the internal combustion based engine. So this internal combustion based engine is, the input to this engine is fuel, maybe the petrol or the diesel. It has also a clutch and the transmission and the differential. And we can see on electric based vehicle, it has only a battery stack, the power electronics converter, the control module, and the differential to drive the wheel, or this motor, electric motor is used. So in this force speed characteristic of this electric vehicle based battery based electric vehicle, we can see that there is no gearing, no gears are available. Okay, so at starting, we can say that there is a very high starting torque, and the torque is decreasing simultaneously, and the speed is increasing thereof. So the gearing system in this internal, electric vehicle, battery based electric vehicle is missing. So we can say that the working of electric based vehicle is much more easier than the internal combustion based engine. Now we will see that what are the types of motor that are being used in this electric vehicles. So the motor are basically comprised of two categories. They are being categorized into two categories, and these motors are nothing but the commutator based motors and the commutator based motors and the commutator less motors. So the commutator based motors are basically the DC motor. So the DC motor are comprised of the commutator motors. So for the control purpose of this DC motor, we can see that the speed control of DC motor is much more easier as compared to other motors. And these DC motors is basically categorized in two ways, that is self-excited or separately excited DC motors. We also know that the DC motor always provides very simple control, since its construction offers orthogonal control of the flux and the torque. And the permanent magnet DC motors are used for low rated two-wheeler applications. So these DC motors have various applications. They are used in two-wheelers as well as they can be used in three-wheeler applications. The other categories of electric vehicle motors are commutator-less motors. In this commutator-less motors, we can say that these commutator-less motors offers high efficiency, they produce high power density, as well as their maintenance is very less, or we can say that they are maintenance free. So the commutator-less motors are maintenance-free motors, and these motors are categorized into three categories, that is the induction motors, the synchronous motor, and the doubly silent induction motors. So all the three categories of motors have high efficiency, and in fact the induction-based motors, the efficiency of induction-based motors, the efficiency may ranges from 85% to 91%. The kind of efficiency that can be achieved if we use rotor copper bars as used in cage rotor motors. So the efficiency can also be increased if we use the cage rotors. So these wound rotors as well as the cage rotor are used by Tesla, and Tesla made the hybrid car based on the Tesla made an electric vehicle based car based on the cage rotor based induction motor. And if we see the wound rotor induction machine, although it has higher weight compared to the cage rotor, it does offer high power density at higher speed with complex control. So this configuration of induction motor is slowly picking up in research domain. So this wound rotor is accepting in research domain, as well as some of the manufacturers keeps on using the wound rotor type of electric motor. The most widely used electric vehicle applications in synchronous machine. The synchronous machine is widely used in electric vehicle, and the reason for using the synchronous based electric motor, because the brushless DC motor, we know that it is very popular in two-wheeler and three-wheeler, and the operation of brushless DC motor is also simpler, and the control aspect of DC motor is also very simple. But in case of commutator-less DC machine, the operation is again simple as compared to the induction-based motors. So the surface-mounted permanent magnet synchronous machine is used as power rating greater than 15 kilowatt. So these type of motor are used where power rating is more than 15 kilowatts. So these type of motor, the stator is similar to that one used in induction machine, but the rotor is fitted with the permanent magnet. So we can say that the BLDC motor are used typically for the rating of 15 kilowatt, and for above 15 kilowatt we use permanent magnet synchronous motor. So for up to 15 kilowatt, we basically relies on BLDC motor, and above that, we try to use this synchronous, this stator motors rather than BLDC motor. And similarly, we have some doubly silent motors, and these motors are basically categorized into switch reluctance machine as well as the stator permanent magnet motors. So the switch reluctance machine has various advantages that this can be used for higher applications. For these motors are used in applications like in buses, trucks. So, but though they can use for high applications, they have several disadvantages also. So that the disadvantages of switch reluctance machine is it produces high noise. They can be more bulkier. They are more complex machines. So these doubly silent, though they are they don't produce noise, but we can say that at for higher applications, they might produce noise as compared to the BLDC as well as the synchronous motors. So the machine design of EV applications is very challenging, and we have to see that which motor is suited for which category of application. That is, which motor is best fitted for two-wheeler, which motor is fitted for four-wheeler. So we have to see the all perspective of these motors. So from this, we can say that the conclusion of this talk is that the speed control of DC motor drive is used at early stage of the electric vehicle development due to its simple control methodology. And also the DC motor drive vehicles are bulkier and require frequent maintenance. To overcome from this problem, an AC motor drive is preferred. So nowadays, maximum electric vehicle available in the market is based on induction motor drive or PSM motor drive. So available motor rating for two-wheeler, three-wheeler and four-wheeler is about 250 watt, 750 to 1000 watt and greater than 1000 watt respectively. So with this, I would like to conclude this talk, and these are the few references. So thank you very much, sir.
Thank you, Dr. Sekhar. Hello.
Yes, sir. Yes, sir.
Thank you very much for your brilliant lecture covering all aspects of the electrical vehicle system. I feel that it will be beneficial to all the participants in the order.
Thank you very much, sir.
Now, Pajja sir.
जी सर, sir.
Can I call you now?
Yes, sir. Yes, sir.
Our third panelist is Professor K.G. Upadhyay, B. M.Tech, PhD, FIE, FIEP, MISc. Professor Upadhyay is ex-professor, Electrical Engineering Department, MMM University of Technology, Gorakhpur. He retired from his services on 36-2021. He has officiated frequently the charge of Vice Chancellor for smooth functioning of administrative system of university in different dates for 364 days. He had been head electrical engineering department 3 times, chief proctor, controller of examination, dean academics, dean PG R&D, dean student affairs, dean planning alumni, dean faculty affairs, president Malviya Alumni Association, coordinator Rashtriya Uchchatar Shiksha Abhiyan, he has organized and attended conferences, workshops, seminars in various received lot of appreciation, awards, and PI of major research projects funded by UGC. He has published 60 research papers, supervised 3 PhD programs, guided 20 MTech. He has also officiated chairman of IET Professional Center, Gorakhpur. He has also authored two books, Conventional and Computer-Aided Design of Electrical Machines in 2004 and Design of Electrical Machine in 2005. He has frequently visited many countries like USA, Italy, Ethiopia, Bangkok, Singapore in various academic capacities and has got international appreciation for the work in the field of electrical engineering. So, he also served as assistant professor at GV University between 1989 and 92. He was truly activated with the various activities of academic and administrative activities of university. He also served Central Electricity Authority, New Delhi Ministry of Energy, Government of India 1985 to 98, and also member of Secretariat Language Committee. In this lecture, the aspect of motor has been covered but for the non-conventional energy sources, main problem in utilization was how to store the energy and for which the battery is used. So Padhyay will explain about lithium-ion powered electrical vehicle. He will explain the advantage of lithium-ion batteries as well as explain about battery management system. He will also explain about the limitations of lithium-ion energy and future development expected. I request Professor Upadhyay to deliver his lecture for the benefit of participants. Thank you.
Thank you, MP Kandoi, sir. So, good afternoon to Engineer MP Kandoi, sir, and other participants, dignitaries, guests, those who are joined in this platform. So, welcome to everybody in the discussion. So, before I come to exactly on lithium-ion batteries powered electric vehicles, I would like to discuss some of the things which are related to electrical sector, like brief history of electrical sector, and then these days we are talking about the sustainable development, and then of course the paradigm shift of the sources for electrical energy power generation and their application. And then I will come to the lithium-ion powered electric vehicles, then availability of the critical materials for electric vehicles, and recovery of the lithium batteries materials, and then extraction of lithium and other strategic elements. So that will be the roadmap for the discussion. So if we see, I hope all of us, those who are involved in the, Shekhar, are you listening me?
Yes, sir.
Can you share the
Okay, sure, sir.
If you share, then before that I'll discuss some of the things.
Okay.
So,
sir, it is not in PPT form. It is a paper. So can I share that paper?
of course you can share. Of course you can share. I do not need to read it, but you share, the audience will have a look. No problem.
Okay, sure, sir.
So if you discuss about the electricity sector, I don't know the time since when it was being used, but its commercial application started with Thomas Alva Edison in 1881, when he designed a power system of few customers, like 59 customers were there with the radius of 1.5 kilometer distribution, and that system was DC system. And then in due course of time, AC system came in, and then AC machines, transformers, multi-phase AC system came in. So there was few years, there was a debate kind of thing that whether DC should be there or AC should be there. But due to advantages of AC system with transformers, in which we can generate at the lower voltage and we can elevate the voltage level at a very high voltage with good efficiency and transmit it to fairly larger distances. And then again, we can step down to the utility level voltage and use it. So these were the beneficial things. And due to that, AC dominated over DC and AC system prevailed. Then again, since we have three sectors like generation, then transmission, and then distribution, major sections. So generation were of course AC, distribution also were in AC, but in transmission sector, DC came in with bipolar DC lines, which has another advantages over the extra high voltage AC lines, transmission lines. So then AC and DC mixed system came in. Here we'll discuss very briefly about the sustainable development and then the paradigm shift. These days we are talking about whatever we are doing technologically or anything, we are talking about or we are keeping in mind the sustainable development. Sustainable development means whatever we are doing for the betterment of the life or society, we are going for looking in the sustainability for a longer period. Sustainability means having the integrated view where ecological balance, environment, and so many other factors which are taken into account. Okay, so whenever we look for these things, we have to have the emissions or the environmental conditions which are very badly being affected by the plants or the devices or the machines or the systems which are being run or operated by the help of fossil fuels. So with the choice to clean the environment for the better development, sustainable development, and also with the fact that fossil fuels has its limit, time limit. Someday it will come that there will be no fossil fuels. So depletion of fossil fuels also compels us to go for the alternatives where we can have the alternative sources of energy which can be used to convert those in form of energy into the electrical energy. And of course, many of us maybe have a know-how that in 1973, when oil crisis were there was a major crunch for the source from which we can convert the electrical energy. And in those crisis period, the focus of engineers and scientists, researchers diverted for the non-conventional energy sources. Earlier to that also it was there, but in 1973 or onward, the focus was primarily diverted, and it was thought of that the research and the efforts should be made to utilize the alternative form of energies like solar energy, wind energy, and so many other forms are available, which are called renewable or non-conventional sources of energy. So many kind of forms were developed. Nowadays we see that wind energy is the prominent energy which is being used for the development of the generation of electricity. Solar energy is being used at the household level, then the commercial level, and it has come up with a huge generation. So if you see the ratio of electricity generation through the conventional sources and through the renewable sources, is changing. So the portion of the renewable is increasing day by day. And that should be there since it is called as the green energy. So whenever we talk of a clean environment and clean society, we go for more and more generation of clean and green energy. That is the conversion of one form of energy to the electrical energy. Since electrical energy is basically the energy which can be easily utilized, motor is the ultimate drive for it. And if you go for, say, my two earlier panelists, Professor K.S. Verma and Dr. Sekhar Yadav, they discussed about the different types of drives, motors, which are being used in electric vehicles. So if you go for the electrical vehicles, exactly the number of parts or the number of portions in the engines which are being used in diesel engine and other engines is substantially reduced. Okay, we take out in any insurgencies, we take out the motor and repair it and then use it. So number of the parts are substantially reduced. So maintenance and other costs reduced in that sense also. So moving into the paradigm shift is that few years back, if you go to look into the system, it was like fossil fuel and nominal alternative energy, renewable energy. Now the portion of renewable energy is increasing, and overall the devices and other appliances which are being used for day-to-day application of our life are being transformed into the primary source as alternative energy or as renewable or the non-conventional. Okay, so it also helps in making the clean environment or the ecological balance. Okay, so in that series, I will be discussing lithium-ion battery powered electric vehicles, which are being the use of the electric power vehicles are uh, increasing, and we are incentivizing the use of electric vehicles. And since we have to use the electric vehicles, we have to have a source from where the power should be supplied to the motor, which is used as a drive for the electric vehicle. So in that process, we have a proposal where we have a review that lithium-ion batteries are featured by high energy density, high power density, environmental friendliness, low self-discharge rate, and long service life. And so it is found out a wide application in consumer electronics areas. Moreover, lithium-ion for electric vehicles has high capacity and large series parallel members, which combined with problems such as durability, uniformity, cost, and safety. In small areas, lithium-ion batteries used with reliability and safety involve the effective control and management of battery system. Okay, so basically it is the battery management system. So we'll talk about the battery management system. And next we'll talk about the limitation of this battery, where it is its performance in the low temperatures. Since in the low temperature, the effect of temperature lower down the availability of battery energy and enhances its impedance. Okay. And at the low temperature, cell degradation shows poor performance. Okay. So we'll basically review the battery management system and the working of the lithium-ion batteries in the lower temperature, aging, and the status of lithium-ion battery. So if you look into the electric vehicle promises future green travel in which fuel consumption engines are replaced with an electric motor, and so reducing our dependency on fossil fuels and less harmful emission will be produced. So electric vehicles can be plugged in parking spaces or office areas during the daytime. And the key to the electrical system achievement is an energy storage system as a battery technology can be applied. Lithium-ion battery is mostly used because of their high energy density, high power density, environmental friendliness, low discharge rate, and long service life. So find out a wide application in consumers. A most common device for weight and power to weight ratio, lithium-ion battery has high efficiency, small weight, less volume, and temperature sensitivity. Battery management system play an important role in prediction of the remaining useful life of lithium-ion batteries. Between battery and electric vehicle acts as a connector. Battery management system is a collection of sensors, communication, control, and computational hardware, software algorithm designed to ensure the high charge, oblique discharge current, and estimation of the state of charge and the state of health of the battery pack from the duration. Battery management system has two main roles of battery monitoring to find out the information like state of health and state of charge and remaining useful life, and also perform the battery in an efficient, safe, and non-damaging way. Lithium-ion battery used in many industries as one of the essential power source. So battery management system is useful and proven. Battery management system has various activities to perform and monitor the estimation of state of charge, state of health, state of life, and state of end, and state of power throughout the life of the battery, and made the right decision for remaining life of the battery. Also, this with lithium-ion battery is processed to the maintenance of intelligent performance, logistics, and activities of system configuration on basis of diagnostics with the goal of producing information to make a timely decision on support and monitoring, charge control, balancing cell function in order to ensure battery safety and reliability. Then let us see the modeling of a lithium-ion battery. Battery models are essential to illustrate the feature of lithium-ion batteries. They are the further first approach to algorithms or management schemes for the performance of battery management system. They mathematically explain the parameters that affect the efficient use of battery, like the voltage, load current, temperature. Dynamic modeling of the vehicle battery system is necessary for battery management system for estimation, monitoring, control, and diagnosis. But it is no easy task because of the large variety of operating environments in the application of the vehicle. So, design of thermal strategy for battery, a whole battery model has a better reproduction of three physical behaviors, such as electrical, thermal, and aging. Models having this behavior are also classified into three various types: empirical, linear, and electrochemical.
केवल अस्थाना सर,
Models in
अस्थाना
each
सर,
type
केवल
of category
वो हैं
differ
श्रीवास्तव
in
साहब हैं।
practical application of their details of level, but still experimental data reproduce, such as charging time and the voltage.
2% only.
Then status of lithium-ion battery and battery management system in electric vehicle.
55, 56 लोग.
Many types of lithium-ion batteries are used in electric vehicles.
Hey,
Generally,
yes, जो है.
power battery cell contains carbon anode, negative electrodes. Now lithium titanium oxide anode is built fast for these type of anode, which helps to increase the battery performance and durability of fast charging. Mostly battery cell voltage and capacity used in Hello.
Yeah.
Hello. Am I audible?
Yes, sir.
Yes, sir, you're audible, sir.
Okay.
Audible, audible.
Please share Dr. Shekhar.
Mostly cell voltage and capacity used in electric vehicles are small. So firstly, a single cell is integrated and packed into the battery module, and electric vehicles battery system consists one or more modules as per the requirement. Usually a battery system consists of 100 to 1000 single cells. A battery management system is very important for managing these single cells, and the BMS in electric vehicles consists of sensors, controllers, actuators, and that have many kinds of algorithms and a single wire. Battery management system has three main tasks in the electric vehicle as cells and battery packs to protect from damage. Then make the battery works with proper voltage and interval of temperature. Ensure the safety and as long as possible service life. Then third one is the battery maintains to operate in the state that the battery should fulfill the requirement of vehicles. Okay, then we can look into the battery management basic framework of the hardware in the figures which is shown here, where it is from the input to the output, and with the digital code, it gives a pictorial view of the basic framework of the software and hardware of the battery management system in the electric vehicles, where we are giving the each and every details from input to the output. Okay, then battery management system have input as main circuit voltage sensor and current sensor to calculate the main voltage and current. temperature sensor measures the cell's temperature, outside temperature of the battery box, and battery coolant inlet and outlet temperatures. Mostly analog inputs such as brake pedal sensor and accelerator pedal sensor, and the digital inputs such as charging allow band switch, start key on off signals, etc. Battery management system have outputs like thermal management module such as fan and electric heater to do the cooling and heating control, balancing module like as switch plus capacitor array, and for battery equalization, dissipation of resistance, voltage safety management as main circuit contactor, battery module contactor, digital outputs such as failure alarm, charging indicator and communication module. Battery management system have internal power supply module and global clock module, and have man-machine interface module and charging system. And it has also the electromagnetic compatibility. The bad processing environment of the electric vehicles has required BMS to work a better anti-electromagnetic interface capacity and send out radiation at low levels. Software of battery management system has following functions. So I will just give the names and a brief introduction about the battery management system softwares. So first is battery parameters detection. In this, total voltage, total current, individual cell voltage detection to avoid overcharging or over discharging, or even reverse polarity phenomenon, smoke detection, temperature detection, insulation detection, collision detection, etc. is done in the battery parameters detection. Then we have second one, estimation of battery states. This consists of the state of charging, depth of discharge, state of health, and state of function, depth of charge. Then state of charge of batteries is essential according to the conditions such as working current, temperature, and voltage. State of health of battery estimates according to battery performance, degradation, and extent of the abuse. Okay, so state of function is estimated as state of charge and state of health of the battery and the environment in which the battery is operating. Okay. Then the third is on-board diagnosis. So in case of on-board diagnosis, the actuators fault, sensor fault, battery fault, network fault, over voltage, under voltage, over current, ultra high temperature, ultra low temperature, loose connection, combustible gas, concentration exceeding, uniformity fault, the rise of over fast temperature, etc. are consist in this onboard diagnostic. Then we have the fourth one, battery safety control and alarm. In this case, it consists of the control of high voltage safety and control of the thermal system. When faults are found, the electric vehicle's control unit are informing the vehicle control through the network and requires to fault handle to prevent the battery from damage or injuries to people raised by high temperature or the low temperature. Okay, overcharge or over discharge or electric leakages, etc. So this is the battery safety control and alarm. So basically this is for the safety purposes. Then the charge control. This consists on the property of its own batteries and the charger power level. BMS can control the charger to the battery charge. The next one is battery equalization. From the information of each cell in the batteries, battery management system adopts the method of equalization as charging equalizing, dissipative equalization, or non-dissipative equalization to make state of charge between cells as consistent as possible. So basically the non-dissipative equalization to make the state of charge between the cells has become important in this case. The next one is the thermal management. Temperature distribution within the battery pack and charge and discharge requirements decide when to start the heating or cooling, as well as heating power and cooling power. So we'll also look into this fact where we know that the lithium-ion batteries are not very fit for operation in case of the low temperature. So we'll again discuss it. Then the next one is the networking. Battery management system disassembling in the vehicle is not convenient, and vehicle required to have network functions at the meantime. Online calibrating and monitoring conduct is desirable. Generation of code is automatic, and program downloading is online for battery management system without reassembling the case. Usually adopt network is controlled area network. Okay. Then the next one is information storage. Store key data battery management system used as state of charge, state of health, state of function, and state of end. Accumulated charge and discharge, ampere hour number, fault code, consistency, etc. The real battery management system in electric vehicle only has some parts of hardware and software mentioned above. There may be at least one temperature sensor and one cell voltage sensor for each battery. Then we have the effect of cold effect in lithium-ion batteries. So as we discussed that it is not suitable for low temperature. The life and the performance of lithium-ion batteries are influenced by the operation of temperature. Okay, mostly they face significant losses in an environment of sub-zero temperatures because of decreases in capacities of power and energy, as well as degradation of battery due to plating of lithium. So this will also review the lithium-ion cell affected by the cold weather from the perspective, performance losses, and aging, etc. Low temperature performance. So we'll look the another component, low temperature performance. The performance of lithium-ion battery is strongly related to temperature. It's crucial to understand why at low temperature this technology bears severe setbacks. Lithium-ion battery performance is minimized at low temperatures. Okay, so some examples are produced. If time permits, I'll explain. Otherwise, I'll go fast and then complete it. So we can just see the outside characteristic of lithium-ion cells in different temperatures, where if the temperature is lowering down, its efficiency or performance is reducing. So performance of 7Ah cells at -60 degrees centigrade with different temperatures, electrolytes can be seen. Then we can also see the aging of lithium-ion batteries. We can see the degradation of lithium-ion batteries, which shows the aging. In the paper, some of the things is not given. I have taken from a researcher from Temple University, United States of America, where paper, can you share one? I have sent you one WhatsApp to you. Can you share that portion? It is regarding the recycling of lithium-ion batteries, availability of the one page is there. You
Okay,
can just.
okay. Sir, what link is there?
I have given you on WhatsApp just before the talk. Okay, so let me just explain. We can share it later. So I'll just have a quick comment about the availability of the critical materials for electric vehicles, and then recycling, then extraction of the lithium and other strategic elements. The rapid growth and expected continual demand for mobile and stationary lithium-ion battery has led to global environmental and supply chain concerns. Critical materials like cobalt, lithium, nickel, graphite, manganese, etc. used in lithium batteries are finite and mined in only a few regions around the globe. Moreover, they are often found and refined in countries with less significant environmental and human health regulations. The demand for graphite, lithium, and cobalt is expected to increase by nearly 500% by 2050, and experts expect that the shortage of nickel within 5 to 6 years, if current trends of mobile and stationary lithium batteries persist. This is a report from World Bank 2020, Mayas Stewart and Mann 2019, Recall Center 2019C. So I'll give the reference. Then let us talk to the recycling for lithium batteries. Usually involves both physical and chemical processes. Harper et al. 2019. And then physical processes usually include pre-treatment and direct recovery of electrode materials. These processes usually include de-assembly, crushing, screening, magnetic separation, bashing, heating treatment, etc. Chemical processes can be divided into pyrometallurgical and hydrometallurgical processes, which use involving leaching, separation, extraction, and chemical electrochemical precipitation. Okay. Then we can look into the recent several sustainable extraction pathways have been developed which recover lithium and other strategic elements from electronic waste using biological systems such as microorganisms and plants. Additionally, the metal-laden carbon-rich recovery agent is used as a precursor for manufacturing new electrodes. The use of end-of-life batteries in the mainstream manufacturing process for synthesis of new electronic components promotes a circular economy. So another kind of economy, which is called as circular economy, is coming into the picture. So these are the things related to the So with this, I will conclude my talk. So in this discussion, we basically a brief review of the battery management system, and then the effect of cold weather on lithium-ion was discussed, and then the availability, recycling, extraction, etc. Were discussed. I invite if anybody want to discuss or have a question on this. I'm very much thankful to the organizers, especially Engineer MP Kandoi sir, who given me chance to discuss these things before the audience. Thank you. Sir, Kandoi sir, over to you. Kandoi sir. Kandoi sir. MP Kandoi sir.
हेलो, अब आ रही है आवाज?
MP Kandoi sir.
हाँ, आवाज आ रही है सर?
हाँ जी सर।
सर ऐसा है, 1:30 बजे से रुके रहेगा क्वेश्चन आंसर सर 20 मिनट का। आपकी इसमें काफी क्वेरीज आई है आपके बारे में। थैंक यू वेरी मच सर। मेरी आवाज जो है बहुत बढ़िया आपने टाइम दिया। आपका ज्ञान तो जो है जैसे नदी को एक कप में समेटना मुश्किल होता है, वैसे आपका ज्ञान को इतने छोटे टाइम में नहीं एक्सप्लेन किया जा सकता। थैंक यू सर।
I am thankful sir.
नाउ आई एम कॉलिंग आवर फोर्थ पैनलिस्ट, इंजीनियर सुरेश चंद। सर आर यू देयर? चंद्रा साहब, चंद साहब, सुरेश चंद साहब, सुरेश चंद साहब, बोला 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 बोला, कोई दिक्कत नहीं। हेलो हेलो सुरेश चंद साहब, सर नाउ इट्स योर टर्न। आप हैं? हाँ नहीं, अभी नहीं आ रही सर, अब भेजिए। हेलो 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 सुरेश चंद साहब, आवाज नहीं आई। हेलो हेलो
अच्छा।
हेलो हेलो
Engineer Suresh Chandra, you are not audible. Please check your mic.
हेलो सर, आप ऑडिबल नहीं है सुरेश चंद साहब। हेलो हेलो Hello. साउंड नहीं आ रही है। ये देखिए आ रहे हैं स्क्रीन पर। नॉट ऑडिबल सर। हेलो, आपकी आवाज नहीं आ रही सर। अच्छा ठीक है, ये आ रहा है।
कंडोई सर वो कनेक्ट नहीं हो पा रहे हैं।
कौन? अभी होंगे सर, होंगे।
चंद्रा
क्या
साहब को अलग से फोन किया जाए दैट ही इज नॉट
मैं
बीइंग एबल।
किया मैंने फोन अभी उनको।
हाँ जी सर, सर
वो जोड़ है। गोरखपुर का डेवलपमेंट तो वही बताएगी ना सर। अनम्यूट कीजिए सर, अनम्यूट नहीं है आप।
बोलने का तो प्रयास कर रहे हैं।
हाँ, जोड़ेंगे।
I think Chandra sir, you rejoin again. Chandra sir, you rejoin again. You leave this meeting and rejoin again, and use
What?
computer audio. And use computer audio while joining this app. You leave this meeting, you rejoin again, and use computer audio while joining. Maybe this sort out this problem.
अब Hello. दो घंटे तक बैठे भी रहे।
Sir, it appears there is some connectivity problem.
हेलो
Sir, Gandhi sir, कोई connectivity problem is there, it appears, sir.
So what should I do, sir?
If he cannot connect, we just give a call to him. Then, if he is not able to connect, we have to curtail it. We have to end it here.
Okay, sir.
Out of time.
Actually, sir, I think,
Give a call to him.
sir, if you suggest to connect with his mobile, I think he has problem with his system. He can connect with his mobile.
Can you connect it with your mobile?
Yes, sir.
Chandra sir?
Just convey to Chandra sir that.
Yes, I am convening. चंदा साहब
जी
अपने मोबाइल से जुड़ जाइए।
अब आपको आवाज आ रही है? आवाज
आ रही है। आई सर आई।
हाँ, लेकिन मैं ना इसको वो भी स्क्रीन भी शेयर करना है मुझको।
तो हो जाएगा।
वो हो जाएगा।
हाँ, let me give you an introduction first, sir.
मैं अभी कोशिश
इंट्रोडक्शन दे रहा हूँ। हाँ, now our fourth panelist is Mr. Suresh Chand. He has done his BTech in civil and MTech from AMU. Are you hearing, sir?
Yes, I am hearing, but I want to share my screen also.
Now, from AMU Aligarh in 1988 and 1990 respectively. In June 1990, he had joined as scientist D in CRRI, New Delhi. He worked there till 1997. During 7 years in CRRI, he had published 7 research papers on various topics. In July 1997, he joined as assistant engineer civil in Nagar Nigam Bareilly and worked till February 2004. In February 2004, he joined as executive in Nagar Nigam Agra and worked till 2015. From October 15 to July 16, worked in Kanpur Nagar Nigam. And then on 31st July 2016, joined Nagar Nigam Gorakhpur as chief engineer. Since then, he has been working here. During his tenure in Gorakhpur, he has been entrusted to beautify different intersections with the help of various businessmen. A number of roads, drains and other facility improves and improvement in solid waste management have been done during his tenure. For improvement of traffic management, ITMS project has been introduced. Electric vehicle buses has been flying on the roads to facilitate traveling for the citizen city. I want to tell the August audience that Mr. Suresh Chandra was pioneer in launching electrical buses in Gorakhpur, and he will present in detail a scenario of launching electrical buses in Gorakhpur as well as overall view of UP. I request you, Suresh Chandra, to deliver your address.
Kandoi sir, I want to share my screen, but how I will share? I am not able to share this. Please tell me.
तो आप बोल दीजिए सर.
नहीं नहीं, मेरे पास स्क्रीन वो है ना, बोलने से तो नहीं हो पाएगा.
स्क्रीन शेयर हो जाएगा सर यहाँ पर.
Sir, you may share your slide to Kandoi sir, or either. Sir, we can.
It is in my computer.
शेखर यादव साहब बताइए how to share.
Yes sir, WhatsApp कर दें आप मुझे अगर सर की PPT we can share.
Okay. Just a minute. Just a minute.
Sir, I am sharing my WhatsApp number to you. You can directly send to me.
क्या होगा? अरे हेलो. हाँ बताइए सर.
Just a minute. I'm sharing, and I'm just sharing like this.
क्यों क्या हुआ? हेलो.
हाँ कंडोई साहब, अब मैं कोशिश कर रहा हूँ, देखिए हो नहीं पा रहा.
तो सर आप एक्सप्लेन कर दें, अगर हो जाएगा तो ठीक है, कोशिश करिए. ठीक है, नो मैटर, वी आर वेटिंग सर.
मेरी आवाज आ रही है कंडोई साहब? हेलो कंडोई साहब.
Yes sir, your voice is coming.
मेरी आवाज आ रही है?
Yes sir, voice is coming sir.
चलिए, आई एम सॉरी.
आपकी आवाज आ रही है.
थैंक यू वेरी मच कंडोई साहब, बट आई एम वेरी सॉरी, मैं आपको नहीं मतलब स्लाइड शो कर पा रहा हूँ, बट मैं बोलूंगा, कोई बात नहीं.
बोलिए बोलिए सर, बोलिए.
Thank you so much. First of all, I would like to pay thanks to Mr. Kandoi sir that he invited me to join this webinar, and I'm very much happy because since I was in CRI in 1990, That time I was attending so many seminars and writing research papers, etc. But I left that. Now, because this is very good experience for me due to Kandoi sir. So I once again pay thanks to Kandoi sir. Now I will start my presentation regarding the electric buses, how they launched in. I am audible? मेरी आवाज आ रही है?
कोई क्वेश्चन? हाँ आ रही है।
ठीक आ रही है?
आ रही है।
Okay, okay. So, government of UP initially selected two cities, namely Lucknow and Allahabad, for operation of electric buses on gross cut contract model basis. सबसे पहले क्या हुआ कि they selected only that is Lucknow and Allahabad, and on 25th June 2018 a meeting was held, and Honorable CM sir gave instruction to take up 7 cities, that is Lucknow, Allahabad, Kanpur, Ghaziabad and Agra, for operation of 100 buses each. So and 2 cities were Gorakhpur and Varanasi. Initially 10 buses for each Gorakhpur and Varanasi were selected, and there were some requirements for this. Number 1 requirement was that depot details where charging infra to be installed, and second was en route installation of charging infra site identification. Third was major routes where the e-buses to be operated with map, and fourth was availability of power for electric vehicles and charging infrastructure. Fifth was bus stops along the identified routes. And the last was who will fund the project in case of capex model. But this was on grassroots, that is grass but model that was there. So there was no capex thing. So municipal corporation, what it did that they find out 0.81 acre land behind BRD Medical College for construction of e-charging bus stop, bus depot. And after that, because the bus were increased to 25 numbers, so we found out a land at Mahesra, that is Mohiripur. And after that, government did that they selected 14 that is cities. One was Lucknow, Kanpur, Agra, Prayagraj, Ghaziabad, Varanasi, Mathura, Meerut, Muradabad, Aligarh, Bareilly, Jhansi, Saharanpur, Shahjahanpur and Gorakhpur. So for these 3, that is Lucknow, Kanpur, Agra, there were 100 buses, and for Prayagraj, Ghaziabad, Varanasi, Mathura, Meerut, there were 50 buses, and Muradabad, Aligarh, Bareilly, Jhansi, Shahjahanpur, Gorakhpur, there were only 25 buses. So 25 buses were there selected for Gorakhpur. We found out 3 number of routes. One route was from Mahesra, that is Mohiripur to airport, and second was that is Mohiripur to Medical College and then Engineering College, that is your Rani Diha. And third was Mahesra to Nosad. So 3 routes were selected by Municipal Corporation Gorakhpur. And for this funding, that is for buses, agency was selected by government of UP, and they did tenders at government level. And the firm was PMI Electromobility Solutions Private Limited. It was selected at UP level. And now they have supplied 15 buses to Gorakhpur, and rest 10 buses will be supplied by this June of this June month. At Mahesra, this our e-charging station was constructed, and an amount of 11.45 crore was sanctioned. 50% was for civil construction and 50% was for electrification, that is external electrification. CNJ was this constructing agency, and Gorakhpur Corporation did regular monitoring and frequent inspections of site and get the work charging station and approach road completed within time frame. And Kandoi sir, you must be knowing that this year there was a lot of rains in Gorakhpur, and our this charging station was submerged. that is up to this plinth level. So we were facing very difficulty in constructing this charging station. Even then, due to these rains, instead of these rains also, we got it constructed in time. And after that, on 29th of December, Honorable CM Sir launched the operation of e-buses in Gorakhpur, and he himself had ride on the bus from Shastri Chowk to Mohadipur Chauraha. 29th of December, this new building of Gorakhpur Municipal Corporation was also inaugurated. And during that time, he launched these 15 buses also, and he had ride from Shastri Chowk to Mohadipur. After a week or so, some challenges came. And what were these challenges? That this e-rickshaw pullers and tempo pullers, they felt uncomfortable, as maximum number of commuters preferred safe, air-conditioned e-buses. Later on, they adapted with little bit changes in their routes. Previously, they were thinking that we will be not getting some passengers in our vehicles, and they all will go to the electric buses. So we got some meeting. We had some meeting with them, and then they came to understand that no problem, we can change our routes. So they adjusted like this. And as far as this income is concerned from these buses, the first day income was only rupees 37,000 per day, and then it increased to 57,000. Then it increased to 67,000. After that, 82,000, and nowadays, on an average, 1 lakh rupees per day is coming through these buses. And the fare of these buses is very less. For 3 kilometers, it is rupees 5 only. And after that, it is increasing, and the maximum fare is only 37 rupees. If you will go from Mahesra to Sahajanwa, then you will give only 37 rupees. While this tempo or e-rickshaw will take minimum 100 rupees or maybe more than this. So it is very cheap also. And for operation of e-buses, an special purpose vehicle has been formed in the chairmanship of Divisional Commissioner, Gorakhpur Division. Director of these means this SPV are, one is Director Urban Transport, Lucknow, District Magistrate, Gorakhpur, VC, Gorakhpur Development Authority, SSP, Police, and Municipal Commissioner, RTO, Gorakhpur, and RM, UP, SRTC. They are all directors of the SPV. So SPV will take care of all the things, monitoring of buses and monitoring of routes and fare, etc. Everything they will take care. And I will tell you very shortly what is the impact of e-buses. E-buses are AC, so it is very comfortable for the passengers. They are preferring e-buses only. If they want to go to some large distance, then they will prefer this e-buses. Very comfortable, and especially in this summer, lesser fare than the other mode of transport. Time saving is there, because if another mode will take that is 30 minutes, then this will take only maybe 10 minutes or 15 minutes. And 2 number of seats are available for handicapped also in this bus. 2 number seats are for handicapped. Panic button is available for emergency if any. So safety is also there. Pollution free. There is no air pollution. There is no noise pollution at all. Because when there are intersections, there are road jam. Then these diesel vehicles or petrol vehicles, they emit a lot of pollution, and they pollute the that is city, and they that's emit noise also. And there is computerized ticketing system in this buses, and there is no fraud at all. Computerized ticket will be there, and it will be already that is recorded in the computer at the charging station. And very soon we are going to integrate these e-buses with ITMS control and command center established in Municipal Corporation, this our building. With completion of integration, real-time location of e-buses will be available in command and control center. which will add to safety and security of citizens traveling in the buses. So this will be additional feature and which will create more safety and security to the passengers. One thing I will like to tell you that 2 more buses are also coming in this Gorakhpur. These are the buses having a capacity of 38 or 40 passengers. But these 2 buses are that is 12-meter floor buses are there, low floor buses, and these were will be using. These will be used for this airport to this your commissionerate, means commissionerate to airport, or you can say this road-based bus stand to that's Air Force. Electrification of this charging station for these 2 buses has been done at our workshop. It is in front of this VC Bangla. Its route will be, as I told you, that from Kachari to airport. Among the source of air pollution, as you know, that vehicular pollution is one of the major sources, and it is going to increase day by day. Air pollution is a major and growing risk factor for ill health in India, contributing significantly to the country's burden of disease. Vehicles are mobile source of air pollution, because there are some stationary sources also, but vehicles are emitting pollution, and they are spreading also very fast. So, and diesel and petrol vehicles emit more pollution at the intersections and where there is a traffic jam. Electric vehicles emit fewer greenhouse gases and air pollutants than diesel and petrol vehicles. Introducing electric vehicles will contribute to improve air quality in towns and cities. This will give us cleaner streets, roads, making our towns and cities a better place to be for pedestrians. In over a year, just one electric car on the roads can save an average 1 to 5 million grams of CO2. Thus, introducing electric vehicles to our towns and cities is the need of the present time, and our governments are committed towards this. So, this was short, that is things regarding the how these electric vehicles launched in Gorakhpur, how they are working and how they are safe and how they are pollution free, and people are liking them
बोलने के
like
लिए इसको
anything.
दबाना पड़
They are all using them, and sometimes we feel that there is passengers are more than the seats. So sometimes they are 1.5 times more, whatever are the capacity of this vehicles. So this was all about how these vehicles launched in Gorakhpur. Kandoi sir.
Thank you, sir. Thank you, Suresh sir.
I'm
you
sorry
get
because
20 minutes. Okay, sir.
thank
Sir,
you.
Verma sahab. Thank you. Verma sahab.
हाँ कन्हैया साहब बताइए.
Sir, there is one query that how much power requirement is increased while charging the electrical vehicles from Virendra Kumar Srivastava?
Actually, the power required is somewhat different with the different size of vehicles, their design of engine, all these things. But while charging the batteries, like UPS inverter is there, some say 6 ampere, 5 ampere is required. So similarly, this again number of cells in the batteries, and this will be the factor deciding the power consumption for the battery, charging of the battery.
Srivastava sahab? Hello? Hello? Sir, there is one more question from Mr. Barun Basar, that about the fire hazards of electrical vehicles. Any person have asked about this question.
During fire hazard?
Of the electrical vehicles.
Yes. So there is some safety precaution taken in the vehicle if fire hazard takes place. This is due to because in the after the development we have less chance of getting vehicles, but there is so many safety measures has been taken to nullify this the case like this.
Suresh Chandra साहब, Suresh Chandra साहब,
जी कंडोज सर बताइए.
there is one question for you. How does economics work with their structure, earning, and capex and running expenses?
Actually, at present, this is not basically economical because this is starting, and later in later time this will be economical because the we can increase the that is trips also. So with increasing trips and etc., this will be economical. But nowadays, because we are giving basically what we are doing, we are saving our environment as well as we are giving this facility to the commuters. So right now we are not thinking that this will be an economical scenario or economical aspect. Recently we are just that is giving that is facilities to the our commuters, and later on in coming time this will be economical also.
Okay. Thank you, sir. Yadav sir.
Yes, sir. Yes, sir.
There is one question: is fast charging is possible in electric vehicles?
Yes, fast charging is possible, sir. But still, yes, sir, fast charging is possible, but we are still working on that. And the research is going on, and in India very soon we have fast chargers, and we can also think of this swapping of battery is also possible in near future, sir.
Okay. Now there is one more question: what are the cooling methods in EV's battery? Dekha Yadav sir.
I think this question may be related to Upadhyay, sir. But
Upadhyay sir hai nahi?
I think he is not there.
Now there is one more question. My MG Mr. Varun Rasagar, my MG jet pipe EV takes in 44 kWh in about 6 hours with about 30 ampere current. What is the reason? आपका mobile दीजिए. Hello. Question answer निकालो. Question answer. Hello. Yadav sir.
Yes, yes, sir. Yes, sir.
He has asked that my MG EV takes 44 kWh in about 6 hours with about 30 ampere current.
Okay.
Join कर रखा. Question and answer. मेरे में सब नहीं है, मेरा बीच में बंद हो गया. तुम्हारे में हेलो.
Yes, sir. Yes, sir.
हाँ. ये बताइए, उसके जवाब बताइए.
Sir, what is the question? Pardon, please.
Question is that my MG Jet EV takes in 44 kW in about 6 hours with about 30 amperes current. Is that proper? Question answer.
I cannot comment on that because
Question answer
maybe the rating of that MG Hector, I think it's taking 6 hours for charging that battery.
Okay. Last question is, why BMS is used in EVs? Battery management system is used in EVs.
I think battery management system is used for controlling and operation of battery. I think it is the more specific.
Okay.
Battery related question. I think it is related to Professor Upadhyay, sir.
Okay, sir. Then anybody have to ask any question? Yes. Any participant? Now, to conclude the seminar, I ask Sri VP Gupta, Secretary, to give a vote of thanks.
I, Ved Prakash Gupta, as Secretary, the Institution of Engineers, Gorakhpur, Local Center, I want to thank all who have spared their valuable time to participate in the webinar. First of all, I want to thank all the officers of our headquarters at Kolkata to approve the webinar as well as their guidance and cooperation at all levels. I am thankful to our President Dr. H.O. Thackeray, Chairman Electrical Engineering Division Professor Sudhir Kumar Kala, Chairman Kate Dr. G. Ranganath for their valuable guidance. I am also thankful to Sandeep Chakravarti, Assistant Director Technical, for his support. After all, the basic purpose of the webinar has been fulfilled by our valuable contributions by our panelists and moderator, Professor K.S. Verma, Professor KNIT, जो सुल्तानपुर यूपी, प्रोफेसर केजी उपाध्याय, फार्मर प्रोफेसर MMUT गोरखपुर यूपी, डॉक्टर शेखर यादव, असिस्टेंट प्रोफेसर MMUT गोरखपुर, इंजीनियर जो सुरेश चंद्रा, चीफ इंजीनियर नगर निगम गोरखपुर, and our moderator engineer MP Kandoi, executive committee member IEI Gorakhpur local center. I am also thankful to our audience as well as who has supported us in any way, directly or indirectly. Thank you.
Now we conclude our meeting. Thanks.
Okay, sir, with permission of the chair, I am ending this webinar.
Okay, then you can end the webinar.
Okay, sir. Thank you, sir.
Okay, thank you, Kandoi Saab. Thank you very much.
Thank you. Thank you.
Thank you very much, sir.
हो गया